Hi, Mr. Heffern here, and here's a video on anthropogenic climate change. So anthropogenic means human-induced in this case. Alright, so global warming. The world naturally does go through warming and cooling phases, which are known as interglacial and glacial eras. But currently the Earth is warming much more quickly than it would naturally do so. In fact, some people say, some scientists claim we should be cooling down at this point in time, except for humans managed to avoid an ice age by burning a lot of carbon. So, yay for us. So, one of the other important factors is, yes, it's normal to have some warming, but we're actually 10 times faster than anything we can find in the ice core samples for previous prehistorical warming records. So for example, we've gone up around 0.8 degrees Celsius just from 1880 to 2012, which means we're going up about 0.06 degrees Celsius per decade, and that supposedly is 10 times faster than anything they've found in the ice core samples, according to NASA. So what? We avoided a great ice age. Why are we worried about it? Well, the question is, can the biosphere actually sustain this? And we're part of the biosphere. If you take a look at extinction rates in the 1800s, it wasn't that bad. 1980, we're talking about maybe 12,000 species a year. In 2010, we're up to almost 40,000 species a year. And it's just climbing like crazy, the number of species that are being affected. Now, this isn't just climate change, mind you. Humans have been, spreading out, changing ecosystems, making farmland, building cities, polluting with plastics and other chemicals. But climate change is one of the issues, for sure. So for example, beehives have decreased from 4.5 million in 1980 down to 2.5 million in 2008. World frog populations have dropped by 90%, and they noticed in the United States they're dropping by about 3.8% per year. So what? Humans can adapt, right? We're not animals. Well, we are, but we're smart, right? Well, we may survive, but will our quality of life be the same? Will our civilizations fall? Are there any precedents? And there is. Yeah, we're a high-tech society now, but I guess if you take a look at some of our low-tech ancestors, Easter Island. The people arrived on Easter Island around 1600 AD. They started cutting down trees to build these giant Moa statues, and eventually someone cut down the last tree. They know from the records the island was 90% forest when humans showed up for the first time, and when the Europeans showed up in 1722 on Easter Sunday, there was not a single tree on the island and no people. And because all the stuff they had built, rotted and fell away, except for these statues. If you take a look at Rome, ancient Rome, first city in the world to have 1 million inhabitants, around 100 AD, and it dropped to 40,000 people just 200 years later. Why? Mainly deforestation, loss of arable farmland, over-farming, and then the barbarian invasions showed up, and that was it. The world entered the Dark Ages. The Pueblo Indians, so these are the Aboriginal peoples in the southwest United States. They were the only group of people to have buildings 3 stories or higher north of Mexico. And unfortunately, they ran out of trees. The farmland was overused. They had droughts, and they had to move as well. And in modern times, just take a look at Haiti or Haitian. They've cut down over 95% of their forests. Every time a hurricane hits them, they're totally destroyed, messed up with huge landslides and other flooding. But if you just take a look at the other side of the island, where the Dominican Republic is located, they still have over 90% of their forests, and they weather the storms just fine. So one of the factors is the Albedo Effect. This measures how diffuse reflection of solar radiation occurs. So, for example, sunlight hits something, how much of it bounces off. So, 0 means it's all absorbed, 100% absorbed, or 0 reflected. all the way to 1, which is 100% reflection. So currently the Earth is on average around 0.29. So 29% absorption and the rest is reflected. As the ice melts, the Earth absorbs thermal energy and it quickly speeds up global warming. So this is a feedback mechanism. So less ice, less reflection, you speed up or accelerate the speed of warming. So as I just mentioned that, right? So here's some albedo effects. Ice has got like a 75% reflection rate, where grassland's only like a 20% reflection rate. So as you convert ice to grass or trees, you're going to absorb the solar radiation more quickly. This has led to another issue too, which is permafrost and methane feedback loops. So as the world warms up, the permafrost starts to thaw and to melt, and all the dead organic material there will start to decay and release methane gas. And this can be set fire with lightning or by humans. And this adds more methane to the atmosphere as well. And methane is like 23 times more effective at warming the planet than carbon dioxide. So as you can see, here's methane and fire up in the Arctic. Here's a vent hole from where some methane exploded in Siberia. And here you can see something that used to be frozen is starting to melt and thaw. Forest fires and peat fires, also another feedback loop. As the planet warms up, you get more drought conditions and flooding, but the drought conditions is the problem. And that leads to forests becoming drier and more easily set on fire. And same thing for the peat that thaws and then can also set on fire. And then that adds carbon dioxide to the atmosphere, and that speeds up global warming too. So here's a forest fire right there, and there's a peat fire. Imagine you saw that coming towards your farm. Okay, ocean absorption feedback. As the oceans warm up, they can't absorb as much carbon dioxide per unit volume, which warms up global warming as well. But they are also forced to absorb carbon dioxide, and that makes the oceans more acidic, which affects sea life as well. So here's a nice graphic here. You can take a look at that. Explains how the carbon cycle can lead to more global warming, and this one as well. So feel free to download the notes from the description. There'll be a link, and then you can peruse them at your leisure. So air moisture as well, another feedback issue. As the world warms, there's more water evaporated into the atmosphere, and water vapor holds thermal energy very well as well. And simultaneously you get more clouds which reflect the light. So we don't actually know if this is helping or hindering global warming, but it is in play. So here's some examples of evaporation and what happens with it over here. And here's clouds over the Earth. Okay, studying climate change. So how do we know climate change is really happening? I mean, after all, written history only goes back a few thousand years. Cave paintings only go back, 20, 30,000 years at most. How do we know, right? So besides the cave paintings, our main source of information is the glacier ice cores. So in Greenland, they've collected ice cores where they take the bubbles out of the cores and see what was in the atmosphere for over 100,000 years worth of data. In the Antarctica, they have over 330,000 years worth of data, and they're drilling further in both places to get further more information. And then they can check that against tree rings to see if their models are working correctly. So far, there are 27 trees ranging in ages of 1,500 to 5,000 years of age. Then if you look at some dead trees that they found, you can get tree ring data up to 10,000 years. The oldest tree in the world right now, I heard about this on the radio recently. It's located somewhere in the States, but they won't tell anyone where it is just to make sure no one accidentally hurts it. Also, coral reef data. It's very similar to trees. Every year they grow more to the coral, and they can use that to also double check the glacier ice cores. And then also we have rock ocean and cave and lake sediments. So pollen and seeds are found in the sediment, and you know what kind of pollen or seeds you would expect in different growing conditions. And also, just on the side fact here, from studying iron in sediment, iron will point in the direction of north. They also know that the Earth's magnetic fields flip from north to south and south to north approximately every 20,000 years, which is kind of cool too. So now we do know for sure, scientists can determine what the climate was like, okay, even before humans could record things. And we've been only recording good data maybe for a couple hundred years, and very accurate data only maybe for like 60, but if you go through the cores, you can go through and see what things were like. So it's kind of cool. So as we study climate change for decades and decades, our mathematical models are becoming more accurate, our predictions are getting better, and same thing has happened for meteorology and weather forecasting. We are able to improve that by 1 day per decade. So for example, a 2-day forecast in 1990, 3 decades later, you can have the same accuracy with a 5-day forecast. So the main people who study the climate change problems are the Intergovernmental Panel on Climate Change, the IPCC. It was founded in 1988 and has over 800 scientists working on the latest report. It took them 6 years. And according to NASA, 97 to 98% of all climate scientists agree humanity is the main cause of present-day global warming and climate change. And the 2% who do not agree, well, their experiments have not been replicable so far. So when you try to repeat their experiments, it just doesn't work. Now, there are some scientists out there who, they have issues with some of the ways the data is collected, or on some of the way, some of the calculations. But generally, even those scientists, when they agree that climate change, global warming is happening, they just disagree on some of the accuracy. If you take a look here, you can see all the different satellites NASA has in space, which they can use to help with the climate change study. Climate change denial. So there are people out there in organizations that deny climate change is happening. Or lately, instead of denying climate change is happening, they're just claiming it's too expensive to do anything about it. One of them was Dr. Tim Ball. He used to be a geography professor in Canada, and then he joined the Heartland Institute and does a lot of talks about why he thinks climate change is a big hoax. And he's been sued a few times. The latest lawsuit, he actually was kind of lucky. It just took too long, so they decided to drop the suit, which he called a win. But here's the hockey stick problem that he had. So here's his version of climate change. This is Michael Mann's version, and they got in a big fight about that. People say the Koch brothers have been putting millions of dollars into funding places like the Heartland Institute to basically lobby against climate change action. Okay, because they're oil barons, they make a lot of money off oil, big oil. And some companies were doing that, but a lot of the big companies, and recently from 2015 to 2020, have been starting to actually get into renewable energy. And Shell Oil for 5 years now has had climate change information on their website. So if you're looking for what the arguments are against climate change and why those arguments are illogical, just go to these two different websites. Skepticalscience.com is really good. And if you want to see who is working against climate change, go to www.desmogblog.com or desmogblog. But really, I'm more interested in what are the arguments for and against. It's good to look at both sides actually, so you can really get a good opinion. Here's Shell Oil and how they have their climate change and energy transitions page. Even BP has now decided that they have to do something about climate change. So here's one of the example arguments. Climate has changed before. Climate's always changing. We've had ice ages and warmer periods, and where alligators were in Spitzenberg. Ice ages occur every 100,000 years, and for the last 700,000 years, there have been periods that appear to have been warmer, despite CO2 levels. And this was from Richard Lindzen, a retired professor from Harvard, so he's got some pretty strong credibility, right? But if you take a look at his arguments, well, this is how they fall apart. Greenhouse gases, mainly carbon dioxide, but methane, were all involved in climate change in Earth's past. When they were reduced, climate became colder. When they were increased, it became warmer. And when the CO2 jumped rapidly, global warming resulted with highly disruptive and sometimes caused mass extinctions. That's what we're worried about. Humans today are emitting prodigious amounts of CO2 at a rate faster than, even more destructive than climate changes in the past. As I mentioned, 10 times faster. And you can go through the argument. This is provided by Howard Lee, who's got a Master's of Science at the University of London and works for Skeptical Scientist. Here's another one too. The temperature record is unreliable. We found U.S. weather stations located next to exhaust fans, air conditioners, etc. You can read the rest of the argument if you like. This is from Anthony Watts, retired weatherman and currently working at the Heartland Institute. And then the counter to this argument is provided by Zeke Housefather, a PhD at Berkeley and the Breakthrough Institute. So temperature data is essential for predicting the weather. So the U.S. National Weather Service and other weather services around the world want temperatures to be measured very accurately. So to understand climate change, we also need to be sure of the true historical measurements. So a group called the International Surface Temperature Initiative is dedicated to making global land temperature data available in a transparent manner. Surface temperature measurements are collected using 30,000 stations around the world. 7,000 of them have long, consistent monthly records. And as technology gets better, our stations are updated with newer equipment. It's got a nice little rebuttal to the argument. As I mentioned before, you can see how climate change denial has changed from it's a hoax to it's just going to kill the economy, and the latest one, it's going to kill the economy and make us all communists. That's pretty weird. But for example, you take a look at the Toronto Sun. Quite often they'll have articles about climate change. They usually are against doing anything about it. So in 2013, here's the article, Climate Change is a Hoax. And then here's the article in August of 2019, Justin Trudeau's carbon tax could kill jobs. So they've gone away from saying it's a hoax to, oh, it's going to kill the economy. Right. It's a new tactic. Same thing happened with tobacco. In the 70s, the big tobacco companies actually hired the Heartland Institute to make it look like cigarettes weren't causing cancer. Eventually they had to give that up. But big oil's 10 to 100 times bigger than big tobacco, so they got a lot more clout. So it is undeniable. Climate change is happening. Even Donald Trump, who started off saying it wasn't happening, has been saying recently in the last couple of years that climate change is real. He just doesn't want to kill the economy. That's his argument. So these are some of the things we're worried about, right? So what are the consequences? As climate change occurs, there are many consequences, and we'll get into that in our next video.